I'm Anil Kumar, and in this video we will learn how to find equation of a trigonometric function from the given graph. The question here is determine the equation of trigonometric function from the graph. Now graph clearly shows that it's a tan function always increasing, right? So in general we can write down the equation as y equals to a times tan k x minus p, let's say plus q, right? Now we'll find different parameters using the graph given to us. We should begin by the vertical asymptotes. Now since you can see that there are vertical asymptotes, let me just sketch them. The lines are very light, so well, here it is. Okay, so that's the vertical asymptote on the left side of, we are just considering one of the graphs here, and on the other side we have somewhere here, right? So okay, so these are the vertical asymptotes. They are at plus and minus 1, as I can see from this particular graphs, right? So let me write their values. These are at minus half and at plus half. Now from the vertical asymptotes, what do we get? We get the time period t. So time period t is actually half minus of minus half. Let me put it in brackets, which is half plus half, which is 1. Once you know t, you can find k, and k is pi by t. Remember, time period for a tan function is pi, not 2 pi, right? So which is pi by 1 equals to pi. So we get the value of k. Now to find the value of a, p and q, we should consider the key points on a tan function. The key points are one where the concavity changes. So this is one of the key points, and the other one is at quarter of the cycle. Now we can see the cycle time period is pi, or in this case time period is 1. Quarter of the cycle is when? Quarter of 1 is what? Quarter is 1 over 4, right? So we'll check values at plus and minus 1 over 4. So that is half for us. So this is 1 over 4, and here this is minus 1 over 4. So if you go down, you get a point here. Okay, now it seems to be at minus 2 from here. Okay, and if you go up here, that is the point, correct? Now I think if you go up, yeah, that is the point, not this one. And here, if you go, it is this point. Okay, so let us assume quarter of a cycle. This seems to be correct, and here it seems that to be the point. The graph is so light. So well, what we will do here is we'll consider, let me now mark with let's say one point is clearly this point, and let us say at this quarter it is this point for us. Okay, and here we have this value. Okay, so we'll consider these 3 points for our equation, right? So it's kind of clear, but the lines are so light that it becomes difficult. Anyway, they have to be symmetric, so that seems to be reasonable. I've drawn this vertical asymptote much closer than it should have been. It should have been right there. Then I think makes difference. Okay, anyway, so what we see here is the 0, 0 point is where it is expected to be, correct? So in a tan function, basically if you compare with the tan function, then 0, 0 point, this is the origin point, it has moved 1 unit up, correct? Therefore there is a vertical translation of 1 unit. So now from here the movement itself gives us a q value. So from that turning point, which is at 0, 1, we get q as equals to plus 1. It seems that the graph has moved 1 unit up. Do you see that? Okay, the other point is at the quarter. What we find is if you use plus quarter value, it is 2 away from there, 2 units, right? So that means that the a value is 2. So using the quarter points, we get a value of 2. The other point is also 2 units away. Do you see that? So a is 2 for you. Now since there is no horizontal movement, we have p equals to 0. I hope you understand what I'm trying to see. So first, find the time period using the asymptotes. From the asymptotes, we get the time period of 1. This is from asymptotes. Okay, and that time period gives you the k value. To find translation, horizontal or vertical, we'll look at a point which originally happens to be at the origin. Now that has been moved 1 unit up, so the q is 1. Then consider at quarter of the cycle. For quarter of the cycle, we are 2 units away instead of 1, correct? So what I'm trying to say is, if you consider tan x, okay, if you consider tan x, in that case the points are 0, 0, pi by 4 is 1, and minus pi by 4 is minus 1, correct? If you compare, this is quarter of the cycle, which is pi. Here it is not 1, not minus 1, right? It is actually 2 units away. It's not 1 unit away from origin. We are just seeing the difference to compare. Do you see that? So that is a simpler way of figuring it out, and that gives us the equation as y equals to a value of 2 tan and k value, which we found as pi. There is no horizontal shift, so we'll write pi x. Is that okay? And vertically it has been translated 1 unit up, so we get plus 1. That is how we can write the equation of the given function. Go through this video once again, try to understand, and see how we can get transformed tan functions equation from the graph. I hope that helps. Thank you.